The question that I am personally most interested in is, what is the nature of dark matter? Dark matter is most of the mass in the universe. It's probably 85% of the total mass in the universe, and we don't know what it is. One of the best places to study dark matter is for a cosmologist like myself, close to home. So the VIA project is looking to do a really detailed study of our own Milky Way galaxy. And in particular, what it's going to do is build two new spectrographs. You put one in the southern hemisphere and one in the northern hemisphere, and that allows you to see the entire sky. VIA has 3 key science goals, and 2 of them relate directly to this question of dark matter, and one of them relates instead to actually understanding the gas and dust in our Milky Way, which is also really interesting for understanding, how our galaxy got put together and how it works. Those first 2 things that have the potential to teach us about dark matter have to do with the dynamics of stars, different kinds of stars that tell us different kinds of things about how the Milky Way got put together. Any galaxy that's kind of a big galaxy like the Milky Way is kind of a typical big galaxy, and any galaxy like that was built up of lots and lots of smaller galaxies that formed early on and then merged together and grew to become the galaxy that we see today. So we have a disk of stars in the center, but then we have kind of the leftovers of many things that built the galaxy up over time. We have a few 100 billion stars in the Milky Way. The smallest of these things are just about 100 stars. Within our Milky Way, we've discovered a lot of these dwarf galaxies. We know now of about 60 of these, and we're expecting to find more soon. The most novel thing that VIA will allow us to do has to do not with these galaxies, but with the things they leave behind as they're destroyed. So when a galaxy here, here's the big galaxy like the Milky Way, here's a small galaxy, it kind of comes in and starts to get disrupted as it gets pulled in, and it'll leave behind a trail of stars, kind of like just a stream of stars that get left behind as this galaxy rotates. What VIA will enable us to do is look for even tinier things. So these are even tinier clumps of dark matter, even smaller than the smallest galaxies that exist. And those small things, which are so small that they can't even form any stars, we expect them to punch holes in these streams. VIA is looking for those holes. And our current theory of dark matter predicts that there should be a bunch of those holes. But they would be created not by galaxies surrounded by dark matter, but by purely dark structures that are only dark matter. So if we find these, this will be a huge confirmation of our current understanding of dark matter, and it will completely rule out a whole bunch of alternatives. If we don't find these holes, it's almost even more exciting, because that would mean that our current model of dark matter cannot be right, because it definitely predicts these holes should exist. Stanford got excited about this project right in the beginning of its design. We were really looking for ways we could make that happen. We weren't sure how to do that until we started talking to the Kavli Foundation. And I think that the funds that the Kavli Foundation brought to the project really enabled us to get it fully funded. Helped bring along the 4th partner, Yale, who is just joining the project now. And we're very, very excited to be working with Harvard and Carnegie on this. And it's an exciting project because it's a small and nimble team that really should be able to do this science kind of with the urgency that it needs. And I think that's something that just would not have been possible without the Kavli Foundation.